The whole being in the dark thing was cool, but it's bad on the eyes. So gonna stop that for a little bit. All right. So going over senescence today, share screen to the screen. Okay. So it's, first of all, every single one of these is going to be like, we need a conference. So I'm no longer trying to like build out each tree, because I'm not going to get anywhere close to accurate, but I'm going to start zooming in on isolated concepts. So for instance, with senescence, one of the questions I had was, in what circumstances is senescence good? I'd like to have like a whole list just there of like every instance where it's like, here's why you need the mechanism of cellular senescence. So I went on the internet and I was like, oh, when is cellular senescence a good thing? And I was scrolling down and I saw that SENS is here, and they basically have like the first, I don't know, like the first Google image, like Google search where it mentions cellular senescence being potentially good. So I went to their page and I was reading through, and lo and behold, they made a mistake in the third paragraph down. The concept of senescence was first discovered in the 1960s by Hayflick and Moorhead, and this is a common misconception. This is incorrect. It was discovered at the end of the 1800s, and it was discovered by a guy named Charles Cedric Monod. And by discovered, I mean it was postulated, because he didn't really have enough direct biological evidence. But basically, if you read through Hedgewick's paper, he talks about senescence as if everyone already knows what it is, and that's kind of weird. So if you go to Monod's paper, and this was 1890 something, or maybe 1882, I forget exactly what date, but whatever. Okay. If we start going down, and all these old papers, they always had these gigantic, like, rambling introductions, which is not a bad thing, not necessarily, but okay. Organisms are created young and grow old, and the old produce new young successors. The passage from youth to old age is best termed senescence, the procreation of the young, rejuvenation. This is written by someone who is making a term up. This is what you'd expect, right? All caps, like I'm making this word up now. And that's fine. So senescence is a property of most, blah, blah, blah. He starts to describe nature of it. Let's see here. The most striking expression is a gradual loss of functional powers of the organism at its end in death, but we know, blah, blah, blah. We know as yet neither the essential character nor the real cause of that loss, because they like to use flowery language back then. Okay, so and it's basically what he understands in this paper is like there's a slow decline, right? And that's the senescence, is like, how come you get weak before you die? Is it like, that's a question, we just accept it, but it actually is a question. It's like, why would you get weaker before you die? Like, why wouldn't you just die outright, right? Like, that doesn't, you know what I mean? Like, okay, so anyway, so blah blah blah, he does a whole bunch of, this is like a long, some animal studies and stuff like that, because that's all they could really do back in the day. But he was looking at, I think it was guinea pigs. Yeah, anyway, we're getting off track. So concept of senescence was first, the concept of senescence was first discovered in the 1800s, end of the 1800s. Anyway, the question then becomes, why does the body use senescence? Okay, so we have one, which is anti-cancer. So we can throw that on here. We're going to create a child. We're going to do uses of senescence. Jesus, it's lagging. We need to scale this thing up. We need to make it faster because this is untenable. Okay. Anti-cancer. Okay. Is preventive measure against cancer, repair when that possible, into unchecked proliferation. It goes into the permanent arrest of the cell cycle. Here's a question. Okay. Let's say that you were a body or a cell, and you could build a mechanism for anti-cancer. Why would you simply shut down instead of just doing apoptosis? That's the real question. And I never actually thought about this before. So why would you do senescence instead of apoptosis? If you do apoptosis, the cell can actually be replaced by another cell. And there's actually no cell in the body that's so critical that you can't replace it, except for possibly like some neurons maybe, or something like that. But even then you have neurogenesis happening. So you can regrow neurons, but like why would you? If it was actually anti-cancer, if the purpose was actually anti-cancer, why would you just keep the cell around? Why wouldn't you just get rid of it and build a new cell? It's not like this is a complicated thing. Cells are dividing all the time, and they're able to like your skin turns over so rapidly. Like 4 to 8 weeks, it's a completely new set of skin. It's not like the body is all like, I gotta conserve energy. I can't, be dividing too much. It wants to divide. Like that's how it actually what's it called? Dilutes damage and stuff like that. So why would it even have senescence if it was actually anti-cancerous? It doesn't actually make sense from the perspective of being anti-cancer, but we'll leave it on the list because it's a theory, and we'll just leave that theory on the list. But that's definitely an asterisk right there. It doesn't make sense. Okay. Instead of devolving into unchecked proliferation, it goes into permanent arrest of the cell cycle, but it should just kill it. I mean, it should just get destroyed, right? So because they're no longer dividing, it might sound like a senescence is inactive, are highly metabolically active. There's so many cellular processes, proteins, molecules that cause inflammation, immune cells to clear up cellular damage, and molecules that can also support tissue repair and remodeling. So this I understand. Okay, so tissue repair and remodeling. Senescence in development. I remember reading something about senescence in development. Senescence is a developmental mechanism that contributes to embryonic growth and patterning. Okay, I remember that part. So embryonic development. Yeah, embryonic development. Okay. All right, so we'll grab this paper. Senescence is a developmental mechanism, contributes to embryonic growth and patterning. Okay, and basically I'm pretty sure what they mean by that is like, when you have the digits forming and stuff like that, it just like, it's basically like a precursor to cell removal. Mouse embryo, chick embryos. The question is, at what stage do senescent cells stop being useful or necessary for development? That'd be after development is over. But how do you know when development is over? That is a good question. So, neural tube, Anyway, I think I've read this paper before, but you can read it if you want to. It's just like, they found out a whole bunch of like senescent cells were crucial to development. Okay. In cancer, solutions in a stable cycle into aging and cancer and other disease states. Inflammation. SASP calls for the immune system. It's always anti-cancer tumor suppressive mechanism. If yeah, I don't know. Let's see here. So let's keep going. Biology of aging, causally evolved, cellular senescence. What, why, how? No. Sean said causal role in aging. Everyone keeps repeating each other. Okay. How about this? We'll go to Sense Direct. We'll do senescence. Good. So senescence, good. Bone homeostasis and disease. Senescence a series of diverse times. It's shown that they also important embryonic development. Late pubertal bone growth cessation. Okay, we'll throw that in there. Bone growth control. Growth. And nope. Adulthood tissue remodeling. I guess that's going to be different from embryonic development, is just tissue remodeling in general. Tissue remodeling. There we go. Here, we review the recent research on cellular senescence and SASP, highlighting the key pathways that mediate cellular senescence, cell cycle arrest, and initiate SASP. Mediating age-associated osteoporosis. Okay, sure. Let's take a look. Senescence and bone homeostasis and disease. Okay. Current somatic, man. And that's senescence been somebody like nobody ever gives Cedric Minot the credit he deserves. Sad times for being alive in the 1800s, am I right? All right. Organize life sentence and telomere length and injection cell cycles and pathways. 1/2 a century later, we know blah blah blah. Including an element two is a complex stress response that can be induced by many stimuli, including but not limited to the end of replicative lifespan telomere erosion, DNA damage, mechanical stress, oncogenic stimuli. For a stable arrest of cell proliferation, multi-component SASP, they're highly bioactive, although proportion of cells and function. Eric's fan, blah 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 blah. Here's a question. Does senescence always end either in permanent senescence or apoptosis slash immune system degradation? Does it necessarily end in those things? Okay, let's think about this. Senescence is defined by most people as a state that is irreversible. Has anyone tried to use aspects of senescence as some kind of a therapy? You know, in young people, you're always trying to kill off the senescent cells, or old people, I should say. And then there's like the theory, oh, if you're young, you kill off all the senescent cells early, then is it going to like slow down your aging process? If you're young and you have an active immune system and your immune system is functional, is like well functional, would it ever behoove you, would it ever be good to activate senescence in certain cells, or even just like blanket activate senescence in a whole bunch of cells all over your body? Remember, the immune system is actually active in a young person, which means that those senescent cells get cleared. Obviously, there's probably been a lot of research trying to activate senescence in cancerous cells. That seems obvious, and that seems like an old thing. But would nobody would ever try to just activate, like induce senescence in a young person's body? Hmm. And then a side thing here. Well, let's go through this first. Side note is using the flu or something like that to using flu. So flu immune response anti-senescence. We'll put that there for later. Okay. Multiple diseases or conditions such as aging, radiation, blah blah blah, senescent cells and blah blah blah. This is old news. What ways? Okay, beneficial rules. Senescence, okay. Soluble, yes, this is known. Yes, nothing new here. Okay. Induced autocrine reinforcement or paracrine transmission senescence could explain some of the detrimental effects. Okay, fine. Yes, inflammaging. Yes. Despite these apparently beneficial role in severe several physical purposes, including hepatic fibrosis control. Hepatic is the liver. Yeah, right. Hema is blood. Hepatic is liver. Hepatic fibrosis control. I'm not sure exactly how, but I will take their word for it for now. Immune surveillance. What What do you mean immune surveillance? You can't just throw that out there like Kang. Okay, maybe it's this one. Krasnovsky. Senescence limits liver fibrosis. No, that's a different. Um, Krasnovsky. Munoz. Ispin. No. Krasnovsky store. Honk. Hoinke. Honik. Immune surveillance of senescent cells. Mouse against cancer and non-cancer pathologies. Oh, whoops. Communicate on their cytokines and then blah blah blah. Pre-malignant senescent hepatocytes are recognized and cleared through immune response. This response to crucial for tumor. It's still tumor suppression, so it's still cancer. It still falls into that. Okay. What about they said add non-cancer pathologies? Broader as a non-cancer. It was where's the PDF? Anti-tumor types, senescent surveillance and early tumor prevention, general context, cancer, non-cancer pathologies. That's, I mean, that's the one, the last paragraph. So hopefully, nothing's okay. Fibrosis, so liver fibrosis still. Hepatic stellate cells, that's still liver. Fibrogenic cell type, senescence. Okay. Where's this for NK to cell dependent clearance of senescent stellate cells. So it's still immune system, natural killer cells. Furthermore, different studies showed that myofibroblast senescence is a program wound healing response to self-limiting organism for fibrogenesis. Initially proliferate and produce extracellular matrix, eventually shown to undergo senescence, thus blocking further proliferation into matrix degrading cells. Okay. That's so wound healing. Similarly shown by PDH that senescent mesenchymal cells accumulating human oral submucous. By telomere is an independent mechanism to ameliorate fibrosis. Orate. Oh, wait, no, wait, what? Where did I see oral? It wasn't oral, it was ameliorate. No, human oral submucous fibrosis. Ew. Okay, that's still aging, and that's about it. So, matrix, so myofibroblast, 37 is here. Okay. What the? 37. Copy, paste. Fibrosis and cutaneous wound healing. Okay. Where- Fibroblastic senescence is a system-dependent wound healing response and cutaneous injury that functions to curb fibrosis during repair. So that's the theory. And that's going to be, it's not, I mean, does that fall under tissue remodeling? Kind of. We'll say it falls under tissue remodeling. Between tissue remodeling and fibrosis control, it seems like the same system. So it's either, we'll say instead of fibrosis, instead of hepatic fibrosis control, we'll just say fibrosis control in general. And that takes care of that. Okay. So good and the bad. So we're down here to show our beneficial roles. Beneficial roles. Let's say it can influence the signaling and differentiation of stem cells. Now, when they say signaling and differentiation, those are involved in tissue repair, regeneration, analysis, promotion, induction, and maintenance of stem cell pluripotency. Induction and maintenance of pluripotency. Why would it have that interaction? But let's say I mean stem cell programming, because that's what you're saying it is, right? That's programming. That's what you're talking about here. Because you're regulating nanog, and that regulates a lot of other stuff. Oh, also promote the reprogramming of microenvironment cells. Okay, well, they straight up said it in the next sentence. And the wound healing process. In response to a cutaneous wound, okay, blah blah blah. We already know this. Therefore, it's important to develop strategies to modulate the condition to enhance positive effects and mechanisms of SP initiation and regulation. Multiple pathways of purpose regulation of senescent cells. Mechanisms are far from understood because we haven't had enough time. No, I think we have a lot of time. We just haven't. We need better ideas. Okay. Time specific and multi-level control. And show that transcriptional rate activation, chromatin remodeling, damage DNA sensing, cause activation. That's just going over inducers. Huh. I saw really through separate signaling pathways because SCP was not induced by the expression of master cell regulatory genes. Okay. So SASP and senescence are separated from each other. So it should just be the senescence unassociated secretory phenotype. Whatevs. And key transdecimal, and NFKB, that's inflammation. Protein B, CEBPB. I don't know what this does. I kind of know what this does, but I don't know what this does. Okay. All right. Cytoplasmic and molecular factors. Imagine activated MAPK. Wait a minute. mTOR. Development of SAS pieces. Of note, stabilization of transcription factor GT forms. And the DNA damage response, kinases, ATM and ATR, but not P. in the cellular related pathways, okay. Hmm. Continue. I think. Okay. We'll see if it's whatever. This is probably a good time to stop. What was it? Immune, has anybody used the flu? Using the flu to induce an immune response to clear senescent cells. Anybody? New kind of senescent cells come out aging. Features, senescent cells. Hmm. Um, Immunotherapy. Mm. Here's the thing. Do we have any therapies that just trigger an immune response? Like a blanket immune response. Like you're just, it just pretends like you're sick, but you're not really sick, right? It triggers an immune response, but you've not put anything weird into the body. It's just like a specific drug that just all it does is trigger an immune response. That's it. So you'll feel sick because most of what you feel when you're sick is immune response, but you won't actually be sick. I wonder, is there a drug, is there a drug specifically to trigger an immune response? Immunosuppressive? No. Immunosuppressant? No. Because here's my belief. What happens, I haven't gotten sick in a very long time. And I think, oh, that's pretty good, but it might not be good. What if it's bad? What if by getting sick regularly, you have a regular immune response, upregulation, which then has there's a wave of senescent cell clearance. Somebody must have list of drugs that trigger an immune response. Immunosuppressant drugs. Why is it always, well, obviously people are more interested in immunosuppressant drugs than not, but I'm sure somebody somewhere has looked into this. So I'll look it up later. But this is a good question. What kind of drugs can you take that will trigger the immune response? Okay, I'm gonna stop recording.